Hello viewers, Wagadarunal taking you through the story of A-level subsidiary mathematics, and this video will be on the topic of indices and use table for students in both senior 5 and senior 6 offering subsidiary mathematics. So an index is the number of times the base is multiplied by itself. For example, if I have 2 to the power 5, most students confused and they think it is 2 times 5, but that is not the case. So if it is 2 to the power 5, it implies that you multiply 2 by itself 5 times. That is why you see here 1, 2, 3, 4, 5. So that is what an index is. Now the plural for the word index is indices. That is why the topic is called indices. But for you to go through the questions on indices, you need to know some of the laws of indices. So when numbers with the same base are multiplied or divided, their indices are operated according to certain rules. Let's start with this rule of multiplication. So the rule of multiplication says that an index of a product is the sum of the given indices. Therefore, if I have a to the power m times a to the power n, I think we realize that the base is the same. It is a. And because there is multiplication here, it implies that you get the sum of the indices. That is why you see a plus. However, if the power is the same for different bases, then it implies that, for example, if it is a, in this case I think we realize that in the previously it was the base which was the same, but there are some cases whereby it is the power which is the same and the bases are different. So in that case, you just multiply these two bases to come up with this, then raise the same power. So those are the two conditions for multiplication. The base can be the same or the power can be the same. Then the second rule is the rule for division. So the index of a quotient. Now quotient is another word to mean division. So the index of a quotient is the index of the divisor subtracted from the index of the dividend. Now dividend is the one in the numerator and divisor is the one in the denominator. Therefore, the index of the divisor is this n and the index of the dividend is this m. Therefore, the index of the divisor is subtracted from the index of the dividend. So this n is subtracted from this m. That is the rule for division, as long as the base is the same but the powers are different. So because it's the division, that is why here you see subtraction. However, sometimes it may be that the power is the same but the base are different. What does that mean? It implies that you come and first divide the bases to come up with this, then raise to the same power. Then the third rule is the rule for powers. So rule for powers, you can be given more than one power. As long as it's more than one power, just know that all those powers will be multiplied. So this time there is this power and there's also this power. All are powers of a. Therefore, it implies that you have to multiply the two powers and put them on the same base. So the letter a has been used in the above examples to represent any number. So a can mean 2, 3, -1, or integers. So it can mean an integer, it can mean a whole numbers, it can mean fractions. And same applies to m and n. So those are the rules. Now there are some things we need to know. One is the zero index. These are special cases. Special cases that any number raised to the power 0 will always be equal to 1. The another one is negative indices. No, this is also a special case. It says that for negative indices, any number raised to a negative index, it is the same as the reciprocal of that very base, but the power becomes positive. I think realize that if this power is negative and you want to make the power positive, you have to get the reciprocal of this and make it and make the power positive. So the note here is that the laws of indices apply to both positive and negative indices. So these values of m and n, they can either be positive or negative, or one can be positive and another one negative, or the rules will still apply. So with that, let's first go through some of the questions. Question 1 says, without using mathematical tables or calculator, simplify this. Now when they said don't use mathematical tables, it implies that they want you to show the knowledge of indices. Because some students, if you don't put there this word calculator, they'll just get a calculator and press the whole of this at once and give you the final answer. But with this word there, it implies that you have to use indices. So indices, this 0.25 is a quarter, this 1 over 64 is that, and this one also remains there. The next is to use indices. 4 is the same as 2 to the power 2, which is there, and 64 is the same as 2 to the power 6, which is there, and 128 is the same as 2 to the power 7, which is there. The next, I think you see that these are multiple powers. There's this power and there's also this power. Now this one can become the reciprocal of this will be 2 to the power negative 5. Sorry, 2 to the power negative 2. So when this one goes up, the power has to change sign. That is why at this step you are seeing here 2 to the power negative 2. Same applies to this. That's why you see here 2 to the power negative 6. Then this one, there are 2 powers. So this time this is negative 14. That is why you see here 2 to the power negative 14. Then these are 2 powers, so you multiply the 2 to come up with negative 4, which is there. These are also 2 powers, you multiply them to get this power negative 12, which is there. Then from there, you remember the rule of multiplication. This is the same base, so you have to add these 2 powers to come up with this. Now when I add these 2 powers, I'll come up with negative 16, which is there. Now from there, we shall use the rule for division. Rule for division says this index of the divisor is subtracted from the index of the dividend. Therefore, it will be negative 16 minus negative 14. Now this minus and minus gives you positive. Therefore, negative 16 plus 14 is negative 2. That is why you see here negative 2. Now to make this power positive, you have to get the reciprocal, and that will be 1 over 2 to power 2. And also we know that this one is the same as 2 multiplied by itself 2 times. So 2 times 2 is 4. That is why you see here 4. So basically that's what they mean when they say don't use mathematical tables or calculator. And now shall go to question 2. It says that evaluate this. So evaluate this is what is given. The first thing we need to know is that 9 is the same as 3 to the power 2 and 27 is the same as 3 to the power 3. Then from there, these are multiple powers. So this times this is a bracket. So this time it means that you will multiply this 2 by this and also this 2 by this. That is why you see here 2y plus 2. Then same applies to this denominator. Multiply 3 by this and also 3 by this to come up with 3y minus 3. Now from there you realize that this is same base. So rule for multiplication says that you add the powers. That is why you see here they are added. Then also this is same base. So the rule for division says you subtract the powers. That is why you see here we shall subtract and come up with this step. But you must be keen to put this bracket. Be keen to put the bracket. Why? Because if you don't put the bracket, this and this will not give you a positive, and that will be vague. Therefore, you must make sure that you show the bracket, and after the bracket, you'll be able to carry out the algebra very well. So this 3y and this 3y cancels, and this one plus this, because there's a negative here, it becomes 5. Then next we shall go to question 3, which says that simplify this. So this is what is given. First we shall use the indices. 8 is the same as 2 to the power 3, and 16 is the same as 2 to the power 4, 4 is the same as 2 to the power 2. The next is multiple power. So this times this, that's why you see here 3n. This one is okay. Then this times this, that is why you see here 8n. And this times this, that's why you see here 2 minus 4n. Then you realize that they are same bases, so same base for this and this. The rule for multiplication says that you add the powers, so I add to come up with this. Also the denominator, you add the powers to come up with that. And when you simplify, you'll be able to come up with that. Now the next we shall use the rule for division, where we shall subtract the powers. So when you subtract, come up with this. And simplifying, this and this cancels, then negative 1 minus 2 gives you negative 3. Then to make this negative power positive, you have to get the reciprocal. Now this 2 to the power 3 is the same as 2 multiplied by itself 3 times. So 2 times 2 times 2 gives you 8. That is why you see here 8. Next we shall go to question 4, which is that simplify this. Now in math, for A-level math, when you see this dot, it implies multiplication. In O-level, the dot would mean operators. They could use star, hash, and other symbols, but in A-level, as long as you see the dot, just know that is another symbol to mean multiplication. Therefore, we shall come and rewrite it, and we put there what we know. So we know that this is multiplication. You shall come and replace the dot with a multiplication so that it doesn't confuse us. The next is to remember that 27 is the same as 3 to the power 3, and this 9 is the same as 3 to the power 2. Now after that, this 6 is the same as 2 times 3 to the power 1. So 2 times 3 gives you 6. That is why we have put here, where there is 6, we have put there 2 times 3 to the power 1. And this one can be expanded to, now we are doing the reverse of the rule for multiplication. So this one is the same as this 3 with this power and multiplied by 3 with this power. Same applies to the denominator. Now this one is the same as, remember this 2 multiplied by this and also by this. Therefore, the first 3 will have the power of 2n, and the other 3 will have a power of 2 times 2, which is 4. Then also for this one, the same case, this type by this gives you this, and this by this gives you that. Now the good thing is that all of them are and have the same base. So what we are going to do, we have to simplify. Now when you look at this, you realize that here 3 to the power 3n is common, and also when you look at this one, it implies that this one is also common. So what we are going to do, we shall first pull them out. Now when we pull this one out, it implies that the remaining for this. Now let's first deal with this part. This part with this power, to get what is here, I will say this divide by this. Now when I divide, this one cancels, but this one same base, you subtract the powers to come up with 3 to the power 2. That is why you see here 3 to the power 2. Then you shall also deal with this and this. So this divide by this, you realize that this cancels, this one also cancels, then you remain with 2. That is why you see 2 here. Then from there, realize that when you compare the numerator and denominator, this and this can cancel, this and this can cancel. So you are going to remain with 3 squared minus 2. Now 3 squared is 9, minus 2 gives you 7. So now let's deal with fractional indices. We have been dealing with indices, which are whole numbers. What if they are fractions? So as long as there's a fraction, it implies that if it is a to the power 1 over n, it is the same as nth root of a. Therefore, if it is a to the power half, it implies square root of a. Note that the laws of indices apply to both positive and negative fractional indices. I think you have already seen that. So with that knowledge, let's go through this question. Question 1 says, evaluate without using calculators this. So first of all, 0.4 is the same as 4 over 10, and this one is the same as 125 over 1000, and this one is the same as 5 over 2. Now when I reduce, this one becomes 2 over 5, and this one becomes 25 the same as 5 to the power 3, 1000 the same as 10 to the power 3. And now this one, I think you realize that the power was negative. To make it positive, you have to get the reciprocal of this. Now the reciprocal means this one goes up and this one goes down. That is why here you see 2 over 5. Now this power, we are doing now the reverse of division with different base and same power. This power affects both of these ratios. Therefore, this will become 2 to power 2 and this will become 5 to power 2. Then here, this power with this is 1 and this power with this is also 1. That is why you see here 5 over 10. Then here this power affects both, so this will become 2 to power 3 and this becomes 5 to power 3. Now to make this division multiplication, you have to get the reciprocal of this. So the reciprocal means this one goes up and this one goes down. That is why you see here 5 to power 3 over 2 to power 3. So now we shall use same base. Remember same base. So same base, when you look at, there is this one and this one and also this one. But remember these two are under the division, therefore that's why you see here this one is positive, then minus this is 2 to power 1, so the power will be negative 1, 2 to power 3, so the power will be negative 3. Then here you have this one which is positive and also this one which is negative because it is in the denominator. So when you simplify, we shall come up with 2 to power negative 2 multiplied by 5 to power 1. Now this one is a negative power. To make it positive, you get the reciprocal. Now this reciprocal, this is 4 and this is 5, therefore in the end we come up with 5 over 4. So that is how we deal with fractional powers. Question 2 says, without using tables or calculator, evaluate this. So we shall first write what is given and simplify. 16 is the same as 2 to power 4, 64 is the same as 2 to power 6, and this 8 is the same as 2 to power 3, to 125 is the same as 5 to power 3. Now next is, these are multiple powers, so this times this, that is why you see here 4 times a half. Then this times this, that's why you see here 6 times negative a third. Then also here, this times this gives you this, and also this times this gives you that. Now when you simplify, this one, 4 times a half is 2, that's why you see 2 there. Then this one also is negative 2, that's why you see negative 2 there. Then this is 2, that's why you see 2 there. And this is also 2, that's why you see 2 there. So 2 to power 2 is 4. Then this one is a quarter, I think by now you know it. Then now this one, 2 to power 2 is 4 and 5 to power 2 is 25. Now because they said we don't use calculator as a table, we have to show the part of LCM. So the part of LCM, the LCM of this is 1, LCM will be 100. Now 100 divided by 1 is 100, 100 times 4 is 400. Then 100 divided by 4 is 25, 25 times 1 is 25. Then 100 divided by 25 is 4, 4 times 4 is 16. Then when I add these ones, I come up with 441, and divide by 100 becomes 4.41. So when they say that you don't use a calculator, this part of LCM must be seen. So now we shall go to question 3, which is that simplify this. So this is what we are given. Now next we shall see that 12 is the same as 3 times 4, therefore that 3 is there, and that 4 becomes 2 to power 2. Then 16 is 2 to power 4, 27 is 3 to power 3, 18 is the same as 2 times 9, but that 9 is 3 to power 2. Now these are different bases but same power, so we are doing the reverse. So this to power this gives you this, and this power this gives you that. Then this power that gives you this. Here it is the same, but here this is 2 to power half and this is 3 squared power half. Then next we remember the rule for multiple powers, so this one is okay, but this one will be this times this to come up with 3, which is there. Then this one will be this times this to come up with a half, which is there. Then this one this times this to come up with a half, which is there. This one is okay, a half, and this one is also this times this to come up with 1, which is The next is to look at the same base. So this and this same base, you add the powers to come up with that. Then also here, this with this same base, you add the powers to come up with that. So this plus this gives you 7/2, and this plus this gives you 3/2. The next is to, now this one cancels, you remain with only these two, which is there. Same base, we subtract the powers to come up with 2 to the power 3. So now we shall go to question 4, which says that x simplify this expression. So that is what we are given. Now we have to simplify. Now simplifying, what we are going to do, we are going to first expand the upper brackets. Expanding means that this one multiplies the whole of this bracket, and that is what is here. Then plus, there is a plus here, so the plus is maintained. Then this one multiplies with the whole of this bracket, this is what you see here. Then for this one, we should remember the identity for expanding a plus b squared. When I expand a plus b squared, it becomes a squared. Now this is a squared plus 2ab plus b squared. Now a squared, this, when I square this, I'll come up with x cubed. The next part is 2ab. Now 2 times this, this is what you see here, 2 times that times that. Then plus b squared, square of this one gives you x to the power 1. Okay, now we have dealt with the denominator. What about the numerator? Numerator, this times this, same base, you add the powers to come up with x power 2. Then also this times this, same base, you add the powers to come up with x plus 1. But remember, there's a minus. Then here there's a plus, which is here. Then this times this, you same base, add the powers to come up with x power 1. Then there is also this minus. Then this times this, same base, you add the powers to come up with x power 0. For the denominator, you are going to simplify. Now when I simplify, you come up, we realize that this times this is same base, so you add the powers to come up with x squared. That is why I say here x squared. Then for this numerator now, this one and this one can cancel. So, and you also know that a number power 0 is 1. That is why you see this one there and this one is here, but this negative has to be maintained. Now that is the numerator. What about the denominator? Denominator, you will realize that x is common, so you factorize out x. This will remain x squared, this will remain negative 2x, and this one will be remain 1. Now for the numerator, there is difference of 2 squares. So difference of 2 squares gives you this difference and addition. Then for the denominator also, this one can be factorized because the sum is 1 and the sum is negative 2 and the product is 1. Therefore the factors will be still the same, negative 1, negative 1. That is why you see here it is a repeated root, repeated factor. Now from there, realize that this and this one power can cancel, so remain with x plus 1 over x minus 1. So that has been fractional indices. Now we shall go to equality of index expressions. Here we shall say that if two index expressions are equal and their bases are the same. Note this word equal, index expressions and also same base. It implies that the indices of these expressions are also equal. For example, if I have c to power a and is equal to c to power b, you realize that this base is the same. As long as it is the same, it implies that even these powers are the same. That is why you see here that a is equal to b. Now that knowledge shall go through some of the questions for you to master the concept. So question 1 says, solve for x. We are given 2 to the power 2x equal to 16. Now 16 is the same as 2 to the power 4. Now after that you realize that this is the same as this, implying that it can cancel and the powers also be the same. Therefore 2x will be equal to 4. Making x the subject, x will be equal to 2. Now we shall go to question 2, which is that given that this is equal to this, find the value of x. So still the same. That is what is given. Then this one is the same as 1 over 5, which is 5 to the power negative 1, and this one is 5 to the power 2. So multiple powers, you multiply them. So this times this gives you negative 5 over 2. This times this gives you 2x. But the bases are the same, so it implies that negative 5 over 2 is equal to 2x. And when I make x the subject, x will be equal to negative 5 over 4. So now I shall go to question 3, which says that solve the equation this equal to that. So first of all, 125 is the same as 5 to the power 3, and 25 is 5 to the power 2. Therefore this side same base, so you have to add the powers to come up with this, and then you come up with 5 to the power 10, and here for this side it is multiple powers, so to multiply them to come up with 2k. Then at this step, 5 is the base is common, so it implies that 10 is equal to 2k. And when I make k the subject, k will be equal to 5. Then question 4 says, given that this is equal to that, find the value of y. So first of all, this 1 over 8 is the same as 8 to the power negative 1, and 8 is the same as 2 to the power 3. Therefore, we shall come up with 2 to the power negative 3 as 1 over 8. Now, same base, you have to equate also the powers. That is why you see here 2y is equal to negative 3. Then making y the subject, y will be equal to negative 3 over 2. And now shall go to question 5, which says that find the values of x and y such that 2 to the power x multiplier, so that this dot means multiplication in Alevel. So 2 to the power x multiplied by 3 to the power y is equal to 432. Now first of all, you shall remember that 432, when you prime factorize, it will be equal to 2 to the power 4 multiplied by 3 to the power 3. After that, we shall just compare, because this and this, it implies that x is equal to 4. Then this with this, it implies that y is equal to 3. So basically, that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded that next video will be on SAT. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on SAT has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.